So suppose that we have two projects. We have, these are the two projects we talked about before. In the first one, you're spending $350 to buy the building, and then you're selling it. Remember the office building example? You buy it for $350, and you sell it for $400 after 1 year. Or in the revised proposal, you buy the building for $350, you find a tenant, and you get $16,000 rent every year for 3 years, and at the third year you sell the building for $450. So in this case, you need to decide which one to do. Of course, these are not mutually exclusive projects. You will either buy the building, sell it next year, buy the building, rent it for 3 years, and sell it after 3 years. So in this case, what we're going to do, we know two methods very well. The one is NPV, the other one is IRR. First, we need to calculate the NPVs, and suppose that the discount rate is 7% here. With 7% discount rate, we actually calculated the NPVs before in the beginning of the first hour. So NPV of the initial proposal is 24,000. For revised proposal, it is 59,000. So which one looks like a better project to you? Would you take the initial one or the revised one? Revised one has higher NPV, so you should pick the revised proposal. So if you look at IRRs, which projects may be better? Is it the 14% IRR one or 13% IRR one? Looking at, remember the IRR rule, the higher the IRR is compared to the opportunity cost of capital in the economy, the better it is, right? So the opportunity cost of capital is 7% is in the economy. So in that case, both projects look good, right? 14 is bigger than 7, 13 is bigger than 7. But which one is more greater, much greater than 7? This one. So actually, if you look at IRR, it looks like initial proposal is a better one. So when you have mutually exclusive projects, IRR and NPV projects may have conflicts. So in that case, what we should do is we should go with NPV. Okay, NPV is safer. So you would go with the high NPV project. And then you can use IRR as a double check. Okay, I'm picking this one. 13% is higher than 7%. So according to IRR, it also looks good. Okay, so NPV rules, basically. You go with NPV. If you have the NPV profiles, so for the initial proposals, this is the NPV profile you have. And for the initial proposal, IRR was around 14% from the table. And for the revised proposal, IRR is 13%. So as you can see, actually, when you're here, revised proposal looks better. When opportunity cost of capital is less than 12.26, it looks better. When the opportunity cost of capital is higher than 12.26 in the economy, then it looks like initial proposal is better. So what we're going to do later is we're going to find this intersection point, actually. And then we will say after which point both decisions will give you the same decision, the same result, let's say. But for now, you can say, okay, we're here, the discount rate is the economy 7%. In that case, revised proposal has way higher NPV compared to the initial one. So we're going to go with the revised proposal. So when you need to choose between mutually exclusive project, what is mutually exclusive? What is mutually exclusive? Onu mı bilmiyoruz? You can either pick A or B. You cannot pick them at the same time. Mutually exclusive projects. So you bought a building. You will either open it or use it for candy store or clothes store, let's say. You cannot have it for both. Actually, you can, which may be interesting. But right? There's like space, and you can use it only for one purpose. So when you, like in this example, you will either buy the building, sell it after 1 year, or buy the building, rent it for 3 years, and sell it after 3 years. So you cannot use you cannot do them both with one office building, right? So you will pick either this one or this one. It means mutually exclusive projects. Okay. So when you have mutually exclusive projects, the decision rule is very simple. Calculate the MPV and pick the project with the highest MPV, with the highest positive MPV, of course. Okay. Okay. So with the IRR rule, what we said is the decision rule is simple, except all the projects whose IRR is higher than the opportunity cost of capital in the economy. Why are we using IRR but not MPVs? One is people like to look at returns, which is like someone will say, okay, IRR is 15%, higher than the opportunity costs in the economy. If you look at the opportunity cost is, let's say, 7%. Okay, IRR is higher than 7%, let's take the project. Very easy to translate. And IRR makes different projects with different sizes comparable. Like in MPV, if your cash flows are very big, like $5 million, $10 million, $20 million, then with calculations, it may be more difficult to figure out what MPV is. And different projects may mean different things for different companies with different sizes. Like for us, maybe $100,000 MPV project is a good thing, but for Apple, it is nothing. Like Apple wouldn't take that project, even if it is positive MPV. But when you look at returns, it's a ratio. It's easy to compare projects for different companies as well. Okay. And also, since we don't have to worry about the discount rate that much in IRR, it may be better to use IRR. With the MPV, remember we said using the right discount rate is very important. Even like a 1% change may change the MPV a lot. In that case, using IRR is a safer bet, let's say. Okay, so these were the IRR things. Let's look at the problems with IRR. Okay, I'm going to focus on three things. One is IRR may mislead you. That's good. Mislead you. IRR may mislead you when you are looking lending or borrowing. So let's look at this example. Suppose that we have two investments. One, you are giving money to your friend. You're giving $100 to your friend. And then your friend will give back to you $150 after 1 year. Okay, did you get it? I'm paying $100 to my friend. He's going to return $150 to me. Or, in the opposite case, I'm taking $100 from my friend, and I'm going to return $150 to him after a year. Okay? So if you calculate IRR for those two projects, one, one case, I'm the borrower. In the second one, I'm the lender. If you calculate IRRs, they will both give you a 50% return, which seems pretty good. 50% is higher than any opportunity cost of capital in the economy. Like for 1 year, 50% is very good. But it is misleading. Why? If you are borrowing at 50%, if you're borrowing at, if you're lending at 50%, it is very good. You're giving the money, you're getting 150, so your return is 50%. So if you calculate MPV with 10% discount rate, let's say, it will be a positive MPV project, and you will see it right away. If you are the person who are lending the money, then it is a bad thing for the person who takes the money from you, because it's a negative MPV project for him. So two projects with the same IRRs, one is good, one is bad. Okay, so you should be careful about those minuses and pluses basically. Bunu anlatabildim mi? İki örneğe baktık. Aynı cash flow. Mirror image aslında. Birinde para veriyorsun, birinde para alıyorsun gibi düşünün. Yani bir tanesinde senin cebinden $100 çıkıyor, sonra sana 150 geri geliyor. You are lending money. Bunun senin için çok iyi. Bu pozitif MPV senin için. Para aldığın zaman arkadaşından 150 geri döndüreceksin. O negatif NPV project oldu. Ama IRR'lara bakarsan ikisi de güzel gibi gözüküyor. So this is the one pitfall about IRR decision, like lending or borrowing. That's important. That's why I'm saying go with the NPV first. Okay. The second problem with IRR is multiple rates of return. So when you have cash flows changing signs all the time, you may have multiple IRRs. In that case, which IRR you're gonna base your decision on is a problem. So let's look at this example. Oops. Ooh. Okay. Okay. Suppose that you have a project like this. You're opening a coal mine, let's say, and you spend $1,000 for that. After that, for 3 years, you're using this coal mine, and it has positive cash flows. In the last year, generally there's like a cleanup cost with the mines, so you have a huge cash outflow at the end of the project life. So if you have something like this, how are we going to calculate IRR? The rule is simple, but finding IRR is not very easy. So what we're going to do is we're going to say we're trying to find the IRR which makes the NPV equal to 0. I have minus 1,000, then I have 600 in the first year. I have 800 in the second year. I have 900 in the third year. And then I have a cleanup cost for 700 in the last year. So it is something like this. I said, yeah, this is very difficult to calculate by hand, but this is, if you plug this in your financial calculator or on Excel and try to find IRR, it will give you an error as well. Why? Because the signs, cash flow signs changes more than once. Normally what we did was we had cash outflow and then cash inflow all the time. We had only one cash flow sign change. In that case, we had only one IRR. But in this example, since the cash flow signs changes more than once from minus to positive, then from positive to negative, you will have two IRRs. So you will have something like this. In the NPV profile, you will have 2 points which crosses the x-intercept. So you have two IRRs. Which one you're going to use? It's going to be a problem. Okay? So when you have cash flows changing signs more than once, you will have more than one IRR, which will be problematic. In that case, what we're going to do, thank God we have modified internal rate of return. So we can use modified internal rate of return, MUR, as another method. So the good IRR is, okay. So let's look at how this is calculated. MIRR is calculated, okay? So what we're going to do is we're going to have the cash flows, and you can use MIRR even if there's no cash flow sign changes. You can still use it. I will show you how it is calculated, then we're going to talk about the intuition behind IRR and MIRR. So suppose that you have cash flows like this. You have the cash outflow of 1,000, then 300, 300, 400, and 700. For modified internal rate of return, what we're going to do is we're going to bring all the negative cash flows to the beginning. We're going to take all the positive cash flows to the end. And from there, I'm going to calculate the discount rate. So let's see how it is done. So I have one negative cash flow anyway. So I have minus 1,000. Then for the rest of the cash flows, I'm going to take them to time 4. How am I going to take them to time 4? You tell me. The cost of capital is 10%. 400 times 1.1. Here I have 300 times 1.1 to the power 2. So I'm calculating the future values. I'm going to do the same thing for this little guy. 300 times 1.1 to the power 3. So, and this, I don't have to do anything to this one. This is at time 4 anyway. So you add them up. So now what you have is you have two cash flows left, right? You have this minus 1,000 at time 0. And then you have 1902 at the end at time 4. From here, I'm going to say, okay, which discount rate makes those two things equal? This is 1,000, the present value. This is 1902, value at time 4. So from the present value formula, I'm going to calculate this discount rate, MIRR, which will be equal to 1744. The decision rule is the same with IRR. If MIRR is higher than the discount rate, you take the project. Just like IRR. If it is higher than the discount rate, you take the project. If there is, remember, the reason why I introduced you to MIRR was because of change of signs more than one time. Here we didn't have that problem. The sign changed only once. Then why did we do it? Because IRR assumes all the cash flows about the project will be reinvested at IRR. So if you calculate 21%, if you calculate IRR as 21%, IRR rule says you're gonna invest all those cash flows at 21% rate, which is not very realistic. You may not be able to find an investment opportunity with 21% in the economy. Okay, so it's not very realistic, basically. So reinvestment at the opportunity cost of capital is a better assumption. What do we do here? Here we are growing this 300 with 10%, which means we're assuming that we are reinvesting this 300 at 10% opportunity cost of capital in the economy. So MIRR has a more realistic assumption. Demek istediğimi de Türkçe söyleyeyim. MIRR'da ne yapıyoruz? Bütün bu cash flow'ları, nakit akımlarını dönem sonuna çektim. Neyle çektim? %10'la çektim. %10 ekonomideki iskonto oranıyla çektim. IRR'da ise bütün bu nakit akımlarının IRR oranıyla tekrar yatırım yapıldığını düşünüyor. Yani bu 300 tekrar yatırılırsa %21'den yatırılır diyor. Çok gerçekçi değil çünkü ekonomide %21 iskonto oranını bulamayabilirsiniz. Bu zaten ekonomideki değer. So MIRR has a more realistic assumption, right? You can reinvest your cash flows at the opportunity cost of capital in the economy. Okay? So even if I didn't have the multiple cash flow sign changes, you can still use MIRR. Okay. So if I had a cash flow change, the sign of the cash flow change, then what am I going to do? Remember, the rule is simple. Bring all the negatives to the beginning, take all the positives to the end. So here I have $1,000 negative, which stays at $1,000. Then I have a positive 300, so I'm going to take it to time 4 by using the discount rate. So this is 300 times 1.1 to the power 3. Then I have this minus 300. This, since it is minus, it should go to the beginning of the project. So it's going to be, how am I going to find this number? 300 divided by 1.1 to the power 2. So this is the present value. That part is the future value. Then we have $400. This is positive, so it should go to time 4. So 400 will be 400 times 1.1. So it will be 440. This 700 is at time 4 anyway, so I don't have to do anything. So add the positive numbers, add the negative numbers, and then put it in our present value formula. So this 1247 time value at 0 will be equal to 1539 at time 4 at the modified internal rate of return. So you take this number, which is 5.39. Would you take the project? MIR is 5%? No. Since it is less than 10%, you're not going to take the project. It's a bad project. Okay? So this is modified internal rate of return rule. The biggest difference between IRR and MIRR is that MIRR assumes that you're reinvesting cash flows at the opportunity cost of capital. IRR assumes all the cash flows will be reinvested at IRR. Okay, that's the main difference. And if you have change of cash flows more than once, you have to use MIRR because you will have multiple IRRs if you can calculate IRRs. Okay, so this may still have the same problem with IRRs. Sometimes it doesn't agree with the MPV rule, like IRR did. But again, what we do is we go with the MPV first and then use IRR or MIRR as the backup methods or the proof methods. Okay. Okay. The third pitfall of IRR was mutually exclusive projects. What is that? You can only take one project, not the other. You cannot take both of the projects at the same time. You have to pick one. So what we're going to do is we're going to look at this example and we're going to calculate IRRs and MPVs, and then we will try to figure out which project is better. So in project A, you have a cash outflow of 9,000. Then you have cash inflow of 3,000, 4,000, 5,000. For project B, you have a cash outflow of 2,000. Then you have the cash inflow of 750, 950, and 1150. As you can see, scale-wise, which project is bigger? A is bigger, right? Its magnitude of cash flows are higher than project B. So what we can do is we can calculate the MPVs first. Suppose that the discount rate is 10%. So if you discount those cash flows and calculate MPV, project A will give you high MPV compared to project B. Okay, then you're going to say this may be because of scaling. Okay, this project has bigger cash flows anyway. So let's look at IRR as well. So if you calculate IRRs, project B will have 18% IRR, project B will have 15% IRR. So MPV rule tells you which project to take. A. IRR rule tells you which project to take. B. So there may be some kind of a confusion. So what we're going to do is we're going to calculate incremental cash flows. So what we're going to do is we're going to take the difference of cash flows for A and B. So here, project A has $9,000 cash outflow. So minus 9,000 minus the $2,000 cash outflow project B has will give you an incremental cash flow of 700. Bunu anladık mı? Eksi 9.000, eksi 2.000, eksi 7.000. So just A minus B. So for this one is 3,000 minus 750, 4,000 minus 950, 5,000 minus 1150, blah, blah, blah. Once you have this once you have this row, you have the incremental cash flows. You can calculate MPV and IRR. MPV is positive. IRR rule also tells you to take the project because IRR is higher than 10%. So in this case, looking at this row only, would you take A or B? A. Why? All the numbers are in terms of A minus B. So apparently A is better compared to B. One more thing. And this IRR will give you the intersection point of A's and B's MPV profiles. Let's go back to this example. And remember, I think 15 minutes ago I said there are different, we have the initial proposal and revised proposal. They were giving you different numbers. And I said, looking at, we're going to calculate the interception points. That will be important. Interception points will be calculated by incremental cash flows anyway. So this is project A. Project A's IRR is here. Okay, 14 something, 15%. Project B's IRR is 18% or so. So you calculate the interception point, which is here, which is what, 13%. So if the opportunity cost of capital is here until 13%, you're going to take the project A, which gives you high MPV compared to project B. After this interception point, project B looks better because it has high MPV compared to project A. Okay? So once you know this point, you can comfortably pick whichever project. because you know where you are in the NPV profiles.
Sonsuza kadar mı yoksa şey mi, şu kesişim yere kadar mı? Tam sıfır.
Anlamadım. Neyi anlamadım?
Proje B'yi seçmemiz bizim oradan sonsuza kadar mı gidiyor
Evet.
yoksa ki
Yani
tam
şöyle,
sıfır üstündeki
sonsuz dediğin bu şey, iskonto oranı maksimum %100 olabilir ki %100 bile olamaz. %100'e kadar aynı bu şekilde devam edecektir diye düşünüyorum. Bu en son fake atıp yukarı dönmesi çok düşük bir ihtimal gibi gözüküyor. Yani şaka bir yana, yok öyle tabii ki, böyle kalacak. Ve burada önemli olan NPV kuralının da aslında her zaman geçerli olduğunu da görüyorsunuz. Yani using NPV rule first is important. But if you're confused, there are other ways. Like if you have mutually exclusive projects, you don't know which project to take, calculate incremental cash flow. So it's gonna give you the same answer with NPV anyway. Okay, so this was the IRR rule. So is IRR good? Actually, it is pretty good, and most of the CFOs use it, as I showed you in the Graham and Harvey graph. But still, I would start with the NPV project, which was the easiest one for us. And then use IRR or other methods as supporting methods. Okay, you don't have to use one method anyway. So NPV is the best. IRR may have problems with the scaling, with the mutually exclusive projects. It has the problems with lending and borrowing. It has the problem with changing cash flow signs more than once. So these are all the problems we see. And the other one was IRR assumes that all the cash flows are reinvested at the IRR, which is not very realistic. So you can use MIRR, modified internal rate of return, which assumes there's reinvestment at the opportunity cost of capital, which is good, but it's still what was the problem with MIRR? It still has problems with mutually exclusive projects. Okay, so start with the NPV first. Okay. Now I have a couple more things. Not too much actually. Okay. I have 10 slides left for some reason. I don't know. Okay, and I have how many minutes? 15. Okay, we are finishing the chapter. Interesting. Did I go too fast? Okay. Normally I can't finish this in 2 hours. Like never ever. No, that's good. Then we will solve questions. That's good. Okay, this chapter is seriously, it's not difficult at all. Like it's very methodological. We don't have we cannot ask very, very difficult questions from this chapter. Like the standard deviation, risk and return chapter, right? It's very straightforward, those 2 chapters. Okay, that's good. That's good. Okay. So let's spend a little bit more time on mutually exclusive projects, and I will just look at 2 things: investment timing decision and projects with unequal lives. Okay, and then I think the last thing I will talk about profitability index, and we're going to be done. Okay, so let's look at this. I will just mention this thing, but this is actually an entire topic. Okay, so we are all up to now. We always said, should I take the project or not? It's like do or die decision. I will make the decision now, and that's it. But real life is not like this, right? In real life, you may think about opening a restaurant, but you may say, okay, I'm going to wait 1 more year. I can take it 1 year later. Or you can say, okay, I will open the restaurant now, and after 2 years, maybe I will close it. So there are lots of options you have when you think about the projects. Now, I will talk about a very simple example, and I will just mention this for 2 minutes, and I will just continue. But if you take my corporate financial strategy class, we talk about real options and all kinds of decisions as well. If you don't want to take the class, it's fine. All the classes are on the internet anyway, so you can open it and listen to it if you'd like. Okay, so let's look at this example. So suppose that you have a tree farm, okay, and you may postpone investing of trees. By doing so, you defer the receipt of the cash flow. So you're not cutting the trees now. You let them grow a little bit more. But you give up the cash You can cut the trees and take the money now, but you're giving this up. But you increase the cash flow in the future. Since the trees grow more after a year, then you may have a higher cash receipt after 1 year. Değil mi? Ağacı şimdi kesebilirsiniz. Neyse. Aklımdan pek çok espri geçiyor. Hiçbirini yapmayacağım. Ağacı şimdi kesebilirsiniz. Keserseniz ne oldu? Para kazanamıyorsunuz. Ama bir sene daha büyüsünler diye bıraktığınız için bir sene sonra daha çok büyüdükleri için daha çok para kazanabilirsiniz gibi bir durum söz konusu. And the opportunity cost of capital is 10%. So what do we do? If you sell the trees today, you're going to make 70. The cost will be 50. So what is the value? What is the profit? 70 minus 50, you make 20. NPV, net present value, since we're at time 0, it is equal to 20 anyway, so you are not discounting anything. So in the first year, your sales are 80, your costs are 55, so your profit is 25, right? 80 minus 55, it is 25. If you calculate the NPV, you have to bring it 1 period back. So it's going to be 25 over 1.1. So it's a 22.7. So you should do it for each year. Okay? Which year is the best year to harvest the trees? Looking at this. Is it the 5th one? Because it has the highest profit? No, it is the 3rd one, right? You calculate the NPV. Why are we calculating the NPV? Because I'm making this decision whether I'm going to cut the trees now or defer the investment today. So again, I'm focusing on net present value. So you're going to cut the trees in year 3. It has the highest NPV, right? Very simple example, but you got the idea. Okay, very good, very good. Then we have projects with unequal lives. So basically, I know that not all projects will have the same life. Okay, some projects will have 5 years, some projects will be 10 years. In that case, what should we do? In that case, we're going to use actually equivalent annual annuity thing. We will talk about it in a second. So what you can do is normally you can compare projects with same lives using NPVs. But if you have 2 projects, one with 3 years, the other one is 6 years, the second one is almost twice of the first project. So NPV rule doesn't give you a very good idea. So what we're going to do, we're going to find NPVs, but then I'm going to look at equivalent annual annuities. So how much cost it will have or how much return it will have every year. And I'm going to compare annual cash receipts, let's say. Okay, it's difficult to understand it like this, but it's easy to understand it over examples. Okay. Suppose that you have two machines, okay? You have machine F or machine G. And you're trying to decide which machine to buy. If you buy machine F, you're paying 15 liras, $15,000, whatever. And then every year, annual maintenance costs are 444. If you buy G, you're paying $10,000. And you can use machine G for 2 years, and the annual expense is 6 and 6. So I will try to figure out whether I should go with a machine F or machine G. I know I can use machine G for less time, but its initial cost is lower. Okay, so there's lots of things going on. What am I going to do? First, I'm going to calculate the net present values. Okay, so net present value is 6%. Cost of capital is 6%. So this is the net present value of machine F. This is the net present value of machine G. So which one looks better? Huh? G looks better, right? It has less cost, basically. So it looks like G is better. But we cannot be sure about it because machine G can be used only for 2 years. Machine F, on the other hand, can be used for 3 years. So in that case, what am I going to do? I will calculate the equivalent annual annuity thing, which is basically the payment in my annuity formula. That's it. So remember my annuity formula. It was present value is equal to payment times PUVFA, right? So in those examples, instead of payment, I'm going to use equivalent annual annuity, okay? So it will give me the annual cost or annual revenue related to the project. Then I'm going to compare the annual payments. So for this one, for machine F, okay? So present value is minus 2569 is equal to equivalent annual annuity. Equivalent annual annuity times PUVFA. The cost is 6%, and this project has this machine can be used for 3 years. Okay? So from here, if you calculate equivalent annual annuity, it will be equal to minus 9.61. Then you're going to do the same thing for G. For G, present value is 21. Equivalent annual annuity times PUVFA with 6% interest rate. And this machine can be used for 2 years. So this time I'm going to write 2. So equivalent annual annuity for G will be equal to minus 1145. Since these are the costs you have to pay, which one looks better, machine F or machine G? F looks better, right? You pay less for the maintenance if you buy F. So now you're almost making those projects' lives equal and you're comparing the annual factors, annual payments. So this is what you can do when you have projects with different lives. Of course, if you consider the revenues, then you should pick the ones with high revenues, right? I mean, here we had the cost, that's why we picked the lowest cost. Here we are picking the highest revenue. So I'm not going to go over this example. The last thing is the profitability index. Profitability index is basically net present value over the initial investment. So how much value you create compared to the money you invested, okay? So suppose that we have something like this. We have 5 different projects. These are the present values. These are the initial investment, cost of the project. So first you need to calculate the net present values. These are all at time 0. Okay, very simple example. So after calculating NPVs, you do NPV minus the investment. Okay, so this creates $1 NPV compared to $3 investment. Bir de dikkat edin, burada negatif almıyoruz. These are not negatives. Even if it's investment, initial investment, don't take it as negative. So it's all about how much NPV you create compared to the investment you make. So they're all positives. So you calculate the profitability index. The higher the profitability index, the better it is. So here, L has the highest profitability index because it creates the highest value compared to the initial investment. So you should go with project L. So basically, what we did was we said, okay, when we are making investment, we should pick the projects that will add value to the firm. If the company has some kind of capital rationing, it means the company has limited funds for new projects. You may have soft rationing. So it's basically the CEO says, I'm going to put a limit on the funds. Everybody does that. Like companies don't spend money like crazy on investments. Or you may have hard rationing. It's basically you have to limit your funding because you don't have enough funds in the capital markets. You cannot find money to support your projects, basically. So as a rule, what we do is, just let me do a quick summary in the last 3 minutes, and I will let you go. So we talk about NPV. So it's basically the present value of cash inflows minus present value of cash outflows. You're accepting all the projects if NPV is positive. For mutually exclusive projects, pick the one with the highest NPV. This is the gold standard of investment. It's the best one that is used. It is consistent with maximizing the value of the firm. The more positive NPV projects the company takes, the more value the company will have. The only problem is, since we have limited funding, we cannot choose all the positive NPV projects. Then we talk about IRR. IRR is the discount rate which makes NPV equal to 0. You accept all the projects if IRR is higher than the opportunity cost of capital. Normally, generally it is consistent with the NPV rule, but there are a couple of pitfalls. One is, for the mutually exclusive projects, it doesn't do a good job. For cash flow sign changes, it may fail to do a good job. And then it assumes that you're reinvesting all the cash flows at the IRR rate. So these are the pitfalls. So you may have a modified internal rate of return if you have multiple cash flow sign changes. And it assumes reinvestment at the opportunity cost of capital, but it also has problems with mutually exclusive projects. For payback period, this was the easiest one. It is time until you recover your initial investment. You accept all the projects if the payback period is less than what the CEO has in his mind as the cutoff point. It's a very quick way, quick and dirty rule of thumb, it says. It's very easy to translate, to tell other people, but it ignores cash flows after the payback period cutoff. And also it ignores discounting, time value of money, and it focuses on short-lived projects too much. To deal with it, you can look at the modified payback periods, where you consider discounting as well. The last one is profitability index. It's basically NPV over the initial investment. Don't take the initial investment as negative when you're calculating it. You accept the projects if profitability index is higher than 1. So NPV is higher than the initial investment, higher than 0. And the highest profitability index is the best one. The problem with that is it may focus on small-scale projects too much. That might be the problem. But you can use it as an additional thing. The last thing is, those criteria are used mostly by CFOs and CEOs. IRR and NPVs are the top ones. And then there comes payback period and profitability index. So it is important for you to understand those methods a lot. Okay, I think we can leave here if you don't have any questions. Do you have any questions? Okay, we will meet on Friday at 9:40.